Now let's look at the chapter 3 specific calculations, where the primary thing was either a discrete or a continuous distribution, finding out the mean, variance or standard deviation or these kind of things about that particular distribution values like this. So if it says a discrete random variable x as a probability function given by this, find the expectation of x, variance of x and the coefficient of skewness. So typically this is a discrete distribution where this is x, this is the probability of x. So it is a distribution first of all because sum of all probabilities is equal to 1. Now when I am talking of expectation or expected value of x, it is nothing but the multiplication and addition. 0.4 plus 0.6 plus 0.6 plus 0.4. So 2 is the mean or expected value of x. Now variance of x, either I can do it as expectation of x square minus expectation of x whole square, which means expectation of x anyhow we got it as 2. So expectation of x squared means you square up all these numbers. This is 4, this is 9, this is 16. So 1 into 0.4, 0.4 plus 4 into 0.3, 1.2 plus 9 into 0.2, 1.8 plus 16 into 0.1, 1.1. Oh, sorry, 1.6. 2 plus 3, 5. So expectation of x squared is 5 minus the expectation of x squared, x whole squared is 4. 2 squared 4. So variance is coming out to be 1. Now the same way you can look at the skewness, because the skewness for us is nothing but expectation of x minus mu whole cube. So either I do it this way, find out x minus mu directly here, right? Or you can expand it and you say expectation of, now that you have got the other two values, expectation of x cube minus 3 into 3 mu into expectation of x squared plus 2 into expectation of x whole cube. So this anyhow expectation of x squared we have calculated it as 5. Right, now expectation of x cube, if you want to find, you can very well do it as this is cube, which will come out to 1 into 0.4, 0.4 plus 8 into 0.3, 2.4 plus 27 into 0.2, 5.4 plus 64 into 0.2, 0.1, 6.4. 7, 12, 14.6. This is expectation of x cube is 14.6 minus 3 into expectation of x is 6 into expectation of x squared we have got it as 5 plus 2 into expectation of x whole cube 8. So this is 16. 14.6 plus 16, 30.6 minus 30. So we are saying that the skewness is 0.6. This is not coefficient of skewness, this is skewness. Skewness is 0.6. So coefficient of skewness is nothing but skewness divided by the standard deviation whole cube or variance to the power 3 by 2. Variance we have already got it as 1. 1 to the power 3 by 2 again is 1 only. So you can very well say that the coefficient of skewness is 0.6. Once the coefficient of skewness is 0.6, probably you may say that it is a positively skewed kind of a distribution. So with the discrete, the typical question that can come out from this particular chapter is mostly to do with this. Either asking you to find out the expected values, the variance, the standard deviations, the skewness, any of these kind of an items. Now the other one is, let's look at the next question then, the continuous part. A continuous random variable y has this particular distribution function. F of y equal to y into y minus 1 into y minus 2 plus 0.4. That is for 0 less than or equal to y less than or equal to 2. It is equal to c, some constant, for 2 less than or equal to less than y less than or equal to 4. So basically the y will lie only between 0 and 4 because it is 0 after that. Now what is that value of c? Here it is a continuous distribution. So in continuous distribution, and in any distribution, first of all, the sum of all the probabilities should be equal to 1. Now the same logic in case of continuous is the integration of all the probabilities should be equal to 1. So when I do the integration here, I have to do it as two integrations. One is between 0 and 2, wherein I will take this expression y into, probably if I expand it, y square minus 3y plus 2 plus 0.4. Basically it is coming out as y cube minus 3y squared plus 2y plus 0.4. Right? So if I integrate this is nothing but y power 4 by 4 minus, so 3 into y cube by 3 is y cube plus y squared, 2 into y squared by 2 plus 0.4 y. This has to be integrated between 2 and 0. So probably it is 2 power 4 by 4, right? 2 power 16 by 4, which is 4, minus 2 cube 8 plus 2 squared 4 plus 0.4 into 2, 0.8. So the first part is becoming 0.8. Then what about the second part? Second part I have to integrate it between 2 and 4. Because the sum of total probability should be equal to 1. 0.8 plus the other one should be equal to 1. So this is c. So it directly becomes c into some y constant. 4 and 2. So it is becoming 2c. 2y. Right, y 4 and 2, which is nothing but 2c. 2c plus 0.8 equal to 1. So giving me that the c value equal to 0.1. So the first part is done. Now I know the c part. The constant is known here. Now the question is about find out the expected value of y as well as variance and standard deviations. So how do I get the expected value of y now? Expected values in case of continuous is nothing but the same integration, but the typical probability function you will multiply with y. It is nothing but y into all that, y cube minus 3y squared plus 2y plus 0.4. So the regular function you will multiply it with y to get your expected value, which is nothing but expectation of x means x into, in the discrete also what are we saying? The probability numbers, we are multiplying it with the corresponding x. That is where we are getting our e of x. Same thing in a continuous case. The probabilities, you are multiplying it with the corresponding x or y value. So which means you are doing an integration now. This plus the other part 0 to 0.2, 2 to 4. Now you know the function is 0.1. This also you have to multiply it with y. 0.1 y. So the first one is becoming, so after integration, the first one is y power 4. So the integration is y power 5 by 5. Then minus 3y cube. So minus 3 into y power 4 by 4 plus 2y squared 2y cube by 3 plus 0.4 y square by 2, and this entire thing you will integrate between 2 and 0. You can substitute the values, and this one 0.1 y squared by 2, this would be integrated between 4 and 2. Whatever the value that comes out, we are calling that as the expected value of x or expected value of y. Now, how do we get the variance or the standard deviation? Standard deviation or the variance was nothing but the variance formula is expectation of x squared minus expectation of x whole squared. Expectation of x just now we are getting. This is your expectation of x, whatever the value that comes. So I have to find out e of x squared. So how do I get e of x squared? Same way, instead of y, you put it y squared. Instead of multiplying it with y, you multiply it with y squared and do the entire process. You are getting expectation of y squared minus expectation of y whole squared. That is what is giving you the variance of y. Take the square root of that, you will get the standard deviation of y. Okay, so that is one more kind of problem. So either you would be given a discrete function or a continuous function, and you are typically asked to find out all these expected values or variances or standard deviations, or probably given the probabilities and some constant kind of number, asking you to find out the constant or solve for something. Those kind of questions are possible. Then what about the next question? A random variable u has a PDF f of u equal to 1 between 0 and 1. Determine the PDF of u squared. Very common kind of question. One distribution is given. He is asking you to find out using that what would be the PDF, the probability density function of something else. U is given. U will lie between 0 and 1. And the f of u equal to 1 for that. Now he will ask for find out for u squared or something else. The simple logic to go about with any of these kind of questions, where probably the next question is also something similar, right? One will do one, the second you can try it out. That will give us the quick confidence also. Anytime one distribution is given and you are asked to find out the other, the PDF of the other, the simple logic is something. Okay, you directly assume first y equal to u squared, whatever has to be found out. So when we say, first we start with cumulative distribution of y, which is nothing but the probability that y is less than or equal to some small y. That is the cumulative distribution of y. So which is nothing but, now if I substitute the things, probability of u squared less than or equal to some y, which is also nothing but probability of u less than or equal to square root of y, right? Probability of u less than or equal to square root of y. Now probably you can find out here for this, What is f of u? Which is probability of u less than or equal to u only. Probability of u less than or equal to u, which is nothing but 0 to u, 0 to u, 1. F of u is what is your integration? Now if I try to look at it, if I try to bring out the similarity between these two things, instead of u I have to use square root of y. Correct? So it is as good as saying integration of 0 to square root of y 1 dx. So which is nothing but x. I have to integrate it between root y and 0. So which will end up as square root of y. What is that? My f of u is nothing but square root of y. But I want not the distribution, cumulative distribution, but I want the probability density function. Which means for whatever the output I get, I take the derivative of this. I take the derivative of d by dx of square root d by dy of square root of y, which is nothing but 1 by 2 root y. This is what will be the probability density function. So square root of y you can very well put square root of u squared, right, which is u, which is also giving you like 1 by 2u. So the probability density function of u squared is nothing but this one. Probability density function of u squared will be working out to 1 by 2u. 1 by square root of y is nothing but u squared. We are assuming, we are taking it because y is something which we have taken as a value. So y is nothing but u squared. So which means the square root of u squared, which is making it u. 1 by 2u is your density function for u squared. 1 is the density function for u, whereas 1 by 2u is the density function for u squared. Yeah, we have to find out this. I mean, it is given as if it is small f, it is a PDF. If it is a capital F, it is a cumulative distribution function. So what we are doing is, we are taking both the functions into the cumulative distribution level first. So here we are finding out the cumulative distribution function of u by doing an integration between 0 to u, whatever is the density function. See, it's like less than or equal to something is the f of capital F of x. Cumulative function is nothing but that value and below. So I am doing 0 to that value u, the integral of 1. That is my cumulative distribution function. Whereas if I am looking at the same here for u squared, the u squared I am trying to write it in the form of u. So it is as good as saying probability of u less than or equal to some square root of y. So I am integrating it between 0 and square root of y. Whatever the output that I have got, that is my capital F of y. But I have to find small f of y, which is giving me that d by dy of that, which is giving it as 1 by 2 root y. For a square root of y, it is nothing but 1 by 2 root y. 1 by 2 root y instead of root y, I am substituting that back. I am getting this value. Probably if we do one more, it becomes even more easier. The next one, C is already giving f of x as lambda e power minus lambda x. Now what is capital F of x? Capital F of x is nothing but 0 to infinite. Lambda e power minus lambda x. This is capital F of x. Or probably 0 to x, not 0 to infinity, because 0 to infinity will give it as 1. So 0 to x, lambda e power minus lambda x is the cumulative distribution function of x. What does that mean? Capital F of x is nothing but probability of x less than or equal to some x. Right? Now going with this, assume y equal to x squared. So when I say capital F of y, it is nothing but probability of capital Y less than or equal to some small y. Y is nothing but x squared. Probability of x squared less than or equal to y, which is same as probability of x less than or equal to square root of y. So which means in this expression, I can always substitute square root of y in the integration part. So I can very well say 0 to square root of y lambda e power minus lambda x dx. When I am integrating it, this is nothing but lambda is a constant. E power minus lambda x by minus lambda. This is getting integrated between square root of y and 0. So minus e power minus lambda root y minus 1. This is what is coming out as the integration. So this comes out as 1 minus e power minus lambda root y. This is the f of the capital F. Now if I have to find out the small f, I have to do the differentiation of this. So differentiation of this is becoming as e power minus lambda root y. E power x differentiation is e power x. And when I do the derivative of lambda into root y, it becomes lambda into 1 by 2 root y. Now you can substitute root y is nothing but root of x squared, which is nothing but x. So you are writing it as e power minus lambda x into lambda by 2x. This is what is the distribution PDF probability density function of y equal to x squared. Minus is there? No, this is a minus, and you are again taking the derivative of this. There is one more minus, right? This is lambda. So e power x, the derivative is e power x. So e power x. So again I have to take the derivative of this. Derivative of this is minus lambda into 1 by 2 root y. So two minuses are going out into a plus. So the most common question in this is only three types. Either he could give you a discrete function, a discrete PDF, and ask you to find out the expected values, the variance, standard deviations and all, or a continuous distribution and asking you to find that out, or transformation of the distribution, giving you one set of distribution and asking you to find out the PDF of something else, right? Yeah. Look at one more question. This is slightly interesting from one of the assignment. Just try this out. So it's as good as the probability of the discrete part is alpha. The probability of the continuous part, which you are integrating between 0 and 1, beta x cube x squared minus x cube. So the integral of the second part is nothing but beta into x cube by 3 minus x power 4 by 4, which needs to be integrated between 1 and 0. So it is nothing but 1 by 3 minus 1 by 4, making it as 1 by 12. So beta into 1 by 12. So the probability of the first part is alpha, probability of the second part is beta by 12. The sum of all the probabilities should be equal to 1. So this is nothing but alpha plus beta by 12, which should be equal to 1. No, when you are summing up the probabilities, it is each individual probability itself. This is a discrete. For a discrete, there is no integration. So cumulative in this case is nothing but 0.4 plus 0.3, 0.7 plus 0.2, 0.9 plus 1, 0.1. So there is no integration involved in discrete. So it's as good as saying f of 1 is equal to 0.4, f of 2 is equal to 0.7. So that's the thing which occurs with a discrete scenario. So there is even the cumulative in this case is alpha only, because there is only one discrete value, right? Cumulative is also alpha only. Only for the second one, if you want to do, which is a continuous, then you can think of 0 to x beta x squared into 1 minus x dx. For that you can find out the cumulative, which is doing the integration between 0 to x. Whereas for a discrete, it is like a discrete point in time. So if you have something like p of x equal to 0 equal to alpha, and if he says p of x equal to 1 equal to some beta, then probably it's like f of 1 equal to alpha plus beta, and whereas f of 0 equal to only alpha. No. That is not the case at all. Discrete is handled discrete, continuous is handled continuous separately. Where did we do this? So obtain an expression for the mean value. So mean is nothing but, now for the discrete part it is 0, probability multiplied by its corresponding x value, which is 0. For the continuous part, it is between 0 to 1. You have to multiply it with x. So beta I am taking out x cube minus x power 4. So it is becoming x power 4 by 4 minus x power 5 by 5 integrated between 1 and 0, which is giving me 1 by 20. 1 by 20 is the mean. The expected value, 1 by 4 minus 1 by 5 into beta. So it is beta by 20. Beta by 20 is the mean. Now in the next question he is saying given expected value of x is 0.4, which means beta by 20 equal to 0.4. So probably beta is coming out to 8. Right? Beta is coming out to 0.8. Beta is coming out to 8. Now you know alpha plus beta by 12 equal to 1. So all you can do is alpha plus 8 by 12 equal to 1. So alpha is coming out to 1 by 3. Alpha is 1 by 3. So which means the probability that x equal to 0 is 1 by 3. And the other part is 2 by 3. Now he is asking for standard deviation of x. Anyhow, expectation of x squared for the discrete part is 0 only. So the standard deviation for the first one is directly 0. For the second one, it is coming out as, again, integration of Beta now you know 8. For the x squared, you will multiply it with x squared. So x power 4 minus x power 5. So when you are doing the integration of this part, it is becoming x power 5 by 5, 1 by 5 minus 1 by 6, 1 by 30 into 8. 8 by 30 is your expectation of x squared minus expectation of x whole squared is 0.4 whole squared, which is giving 0.16, and probably expectation of x squared is 8 by 30. No, what is that expectation of x squared? 8 by 30, which is 4 by 15. 4 by 15 whole squared minus 0.16. So what is the 4 by 15 whole squared? 4 by 15 whole squared minus 0.16 coming. Something we made a mistake. Can't be negative. Expectation of x squared minus expectation of x whole squared. Oh. You see, even here it is there. No? Here the expectation of x. See, now you have got the mean is 0.4. So here also you have to do it as when you are doing expectation of x minus mu whole squared for variance, which is nothing but expectation of 0 minus 0.4. So there is the expectation of 0.4 whole squared, the discrete part. See, here you are getting expectation. When you are saying expectation of x, it is both for discrete as well as continuous for the whole distribution. So in the discrete case, when you are doing expectation of x squared, you are doing it as x minus mu whole squared, variance. So expectation of x is 0. 0 minus mu, for us now it came out as 0.4 for the whole distribution. So it is actually coming out as 0.4 squared into alpha, which is 1 by 3, plus whatever we have done, the beta part. See, we have to find out for both of them, right? Expectation of x squared minus expectation of x whole squared was there. The expectation of x whole squared, expectation of x is 0.4. That also has to be, so it can't be 0 there. So it's as good as saying I am doing it as x minus expectation of x whole squared. X is 0. Expectation of x whole squared is 0.4 whole squared. That see, the variance is nothing but expectation of x minus mu whole squared. That is where we are doing it as expectation of x squared minus expectation of x whole squared. We are not finding the mean separately for that and separately for this, right? This is the mean of the continuous, the two put together. So the mean of two put together is 0.4. So all it has to happen is expectation of x minus mu whole squared for the discrete part. Mu is 0.4. So the value multiplied by its corresponding probability. 0.16 into alpha. That is for the discrete part. For the continuous part, I'll do it as beta, which is 8, into the one I will multiply it with x squared. So which is x power 4 minus x power 5. I do the integration of this part. This is giving me expectation of x squared minus expectation of x whole square. Or here also I do the same thing. X minus mu directly I will do. Right, because the variance is nothing but expectation of x minus mu whole square. X minus mu is already there, 0.4. I subtract 0.4 across, and I can directly do it as integration of 0 to 1, 8 into x minus 0.4 whole squared into x squared into 1 minus x. The integration of this will directly give me the variance of the continuous part. The variance of the discrete part is already available. The summation will give me the total variance. Right, here we have to be careful with that because there are two distributions involved. I cannot directly take for the first discrete, I cannot take it to be 0 because I have it as 0.4 whole squared also excessively that is present. So it's as good as, see, it's as good as we are doing expectation of x squared minus expectation of x whole squared. Expectation of x, you already know that it is 0.4. Expectation of x squared means what? You are doing x squared into this for the discrete part, and for the continuous part also you are doing the same thing. Whatever is the thing you are getting it as expectation of x squared minus expectation of x whole squared, which is 0.4 whole squared. You are getting the same answer for total, because we got it also like this only, right? So beta by 20 is what the expectation of x, which is for both of them, and that is what we have equated it to 0.4 and set beta equal to 8. So it's for the whole distribution, right? So typically you see these kind of numericals in continuous and discrete from this particular chapter, right? Just practice. I think the assignment is containing this, and a couple of those things are from the practice questions. So just go through those things. That will give you a complete hold on the numericals from this chapter is concerned. So then you can start practicing a couple of questions from the exam.